Factorizing sum of two cubes. In a previous video, we treated factorizing difference of two cubes. In this video now, we are asked to factorize A, m cubed plus n cubed, B, m cubed plus 64n cubed, and C, 27m cubed plus 125n cubed. Let us start with the first one, m cubed plus n cubed. Now, when you have two cubes like this, m cubed, n cubed, related by addition, it is called sum of two cubes. And just like difference of two cubes, when you factorize sum of two cubes, the answer is always in this pattern. The base of the first term plus the base of the second term in one bracket, that is m plus n in one bracket, and then the square of the base of the first term, which is m square, minus the product of both bases, which is m times n, which is mn, then plus the square of the base of the second term, in this case n square. This is the answer to number 1. So just note that whenever sum of two cubes is factorized, the answer comes out in this pattern. Where it is different from difference of two cubes is that in difference of two cubes, these two signs are plus, while the sign here is negative. Whereas in sum of two cubes, you have this sign here to be negative and this is what? Positive. Please take note. Number B, m cubed plus 64n cubed. We are going to first express the terms to look like what we have in A. So that we have m cubed plus 64 can be expressed as cube, which is 4 raised to the power 3. Then multiply n cubed. So we have this as m cubed plus, now 4 has cube and n has cube. So we can bring the two together as 4n and represent them with 1 cube. So when you look at these two terms now, it looks very similar to what we have in A. So this now is sum of two cubes. Remember the pattern, which is base of first term plus base of second term in one bracket, that is m plus 4n in one bracket, then the square of the base of the first term, which is m square, minus the product of both bases, which is m multiply 4n, and then plus the square of the base of the second term, which is 4n square. So that the final answer comes out as m plus 4n in one bracket, then m square, m plus 4n minus 4mn plus 4 square is 16, 16n square. This now is the answer to number 2. Alright, let's go to number 3, 27m cubed plus 125n cubed. We are going to express both terms all in cubes. 27 is the same thing as 3 raised to the power of 3, then multiply m cubed, plus 125 is 5 raised to the power of 3, multiply n cubed. What we have here, 3 is cube, m is cube. So we can bring both together, which is 3m, and represent them with 1 cube. Similarly, we bring 5 and n together, which will now be 5n, and represent them with what? 1 cube. So here now we have sum of two cubes. And don't forget the pattern. The base of the first term plus the base of the second term in one bracket, which is 3m plus 5n in one bracket, and then the square of the base of the first term, which is 3m square, minus the product of both bases, which is 3m multiply 5n, then plus the square of the base of the second term, which is 5n square. So that the final answer comes out this way. We have 3m plus 5n in one bracket, then 3 square is 9, so that we have 9m square, minus 3m multiply 5n is 15 nm, plus 5 square is 25, so we have 25 n square. This now is the answer to number C. Thank you very much for watching.